One of the main reasons that we use pointers is to pass by reference and be able to make changes to our variables without having to pass in their values and without having to return those values to ourselves. So we have seen passing by value a lot before. I'm just going to take a look at order.c here. So in this C file, our goal is to make a function that can put two numbers in order. So for example, if my function is passed the numbers 10 and 5, then I'd like to put those numbers in order. I'd like to make the first one that was passed into a 5 and the second one that was passed into a 10. But we've seen that C functions can't return more than one value. So I might hope to do maybe something like, I'm going to call my function order, so I want to pass in something like num1, something like num2. But in the end, I also need to potentially change num1 and num2. And so maybe I might want to try to write something like this, but I can't in C, right? I can only return one thing. And so this is where passing by reference comes in. So the idea is that if I can actually just pass in the address of num1 and num2, then I can change them in place and I don't need to even return anything. So we've actually seen this already with arrays. I think in at least one program and maybe one lab, we have actually been changing arrays by passing them by reference. But hopefully this makes that even more clear. So in order to pass our double types by reference, we're going to need to pass their addresses. So when we actually call this function that we're going to call order, we're going to pass in the address of num1 and the address of num2. And we'll see how we actually use these addresses, which are pointers. So these addresses are pointers to num1 and num2. So we're not going to return anything, as we already saw from how we call our function. But when we pass in these addresses, we're going to need to say that we're passing in a pointer to a double, and maybe we call it A, and we're passing in another pointer to a double, maybe we call it B. Now, what do I want to do? I want to say if A is greater than B, but not really, if what A points to is greater than what B points to, then I need to swap them, right? So how do I make that check? I can say if now here, so in when I was defining my inputs, this star up here was saying that this variable is a pointer. Now I'm going to use the star to be the indirection operator. So this is saying whatever A points to is greater than whatever B points to. Now perform the swap. So I'd like, if I do anything like setting A or setting B, what would that do? That would just change the actual addresses that these represent. So if I want to make any changes, I'm going to have to, again, use the indirection operator to say, change what A points to and change what B points to. So I want to change what A points to be whatever B pointed to, but at this point, if I just ran this, then I would no longer have access to the value of whatever A points to, so I should save that. I'll make these are doubles, double temp. Maybe I should actually Oh no, that's fine. So my double temp is going to be whatever A points to. Then I will set whatever A points to be whatever B points to, and then I can set B to temp. And maybe at this point, let's just run this to see if we have any compiler issues. We're not using num3, that seems fine for now. And we don't get anything going wrong when we run it, so that's good. So we probably should take a look at what our variables are, right? So num1 is sum double, and num2 is sum double, and they are num1 and num2. So, oh my gosh, I keep doing this. Okay, printf is what we want. Oh, I don't have my, include. Okay, so at first, these num1 should be 8.5, num2 should be 12.01. So after I call order, I actually don't expect these to change because they're already in order, right? So let's just run this, see what happens. And it looks like I forgot some equal signs, and it's probably going to be easier for us to see if we use the 0.2 here. So let's just do that. And I put my 0.2 in the wrong spot. Okay. Okay. So yeah, they didn't change, which is what we expected. But now, when I call, now let's say I want to order num2 and num3. So what we want to happen is, so num2 is 12.01, num3 is 10.9, so we want num2 and num3 to switch, because num3 is currently smaller than num2, but when we put them in order, it should be swapped. So let's call our function and then take a look at what we get. And so here we have something that will print them out. Maybe I'll put this above just for organizational purposes. So now we're hoping they start out in their original order, but then they're going to be in order when we print a second time. And that is indeed what we get. We see num2 was bigger, but now num2 is smaller. So this is an example of passing by reference, and this is what you're going to do for the classwork for our pointers day, is practice passing by reference. And an easy time to know when you need to pass by reference is when you kind of want to return more than one thing, but we can only return one thing in C. Stylistically, sometimes it's nice to pass by reference even when you didn't need to, but definitely when you need to change more than one thing, you're going to have to pass by reference, and that is what pointers get us.